Although the trigonometry is pretty complicated, generators make hip roofs almost as easy as a gable roof. Let's see how they are done. The only difference between a standard roof and a hip roof is that the ridgeline does not extend all the way from one end of the roof to the other. It's shortened to the value specified by the ridgeline width, which itself must be less than the panel width value. And the difference between these two fields is the amount of the indent at the ends. So, for a hip roof, just specify all the other general parameters as needed for a standard roof, and then specify the length of the ridge line width. When you hit the Generate button, you will create a roof panel as before, but this time the panel will have triangular cutouts at the ends. After the SCAD file is created, the generator will note that you have entered a value for the ridge line width and ask if you would also like to create end caps, and you should accept the offer, giving the SCAD file a different name than the roof panels. And for your information only, at the end of the process, the notes box will contain information about an end cap angle. Now process the roof panels and the end caps through OpenSCAD. I start by importing the roof panel, duplicating it, and aligning the two pieces as I demonstrated in the tip on aligning roof panels. But now I import the end cap STL, make a copy, and flip the copy front to back so that the insides of the end caps are facing each other. Now select one of the end caps and the joined roof panel group. Click on the Alignment tool and align the points of the triangular end cap with the ridge line of the roof, and then the end of the roof with the end of the end cap, and group these two pieces. The peak of the end cap should now be nestled perfectly in the triangular hole of the roof panel. Repeat the process for the other end. Your four pieces should now be perfectly aligned. Before printing, I like to rotate the combined parts 45 degrees towards its back and 45 degrees clockwise so that it is standing on a corner. I then export it as an STL file and import it into my slicer, where I print it using slicer-generated supports. As soon as possible after the print is done, remove the supports before they harden to the roof. For me, even though removing the supports can be a bit challenging, printing the roof this way gave me the cleanest print. One other observation. If the end caps appear to be a bit indented into the main panels, you can move them back a bit, perhaps 0.5 to 1.0 millimeters, prior to grouping to get a joint that is a bit more flush.